Hello friends, welcome to part 2 of our machine learning the future course Simple Linear Regression. So in Simple Linear Regression we have already seen the initial part where we have implemented the data preprocessing template to our Simple Linear Regression model. For few of our Anaconda Spider versions, the test size which we have stated in a previous video as 1/3 was not implemented properly, due to which our X test and our Y test was not displaying proper. So if that is your case, or if that error comes to your case, so you can obviously write it in your decimals and then try to execute this query as control enter, and you can properly see your X test variable and your Y test variable. So we have already implemented the data preprocessing template. Now let's start the simple linear regression model. So before starting with the simple linear regression model, what we have done till now, so what we have done is we have created the X test, X train, Y test and Y train. So we have a data set which consists of dependent and independent variable. We'll be supplying this data set to a machine learning model. We'll provide the inputs as well as outputs, and then we'll provide it a training set. That's why we have split it into a training set and test set. So we'll provide or input the training set to a machine learning model, and then we'll try to predict our dependent variables values, which is Y, with the help of the learning which the machine learning model has been implemented or has learned based on our training set. So that's our aim. So let's start. So our next step is fitting simple linear regression to training set. So that's what we are told. Now we'll fit our training set into our simple linear regression model. So for that we'll use scikit library. So for sklearn dot linear model will import a class which is known as linear regression. So let's create an object of this. Regressor is equals to linear regression. So after creating the model, let's fit our model. Regressor, so what method will you use? Dot fit. So regressor dot fit, and what will be the input here? As you can see in the arguments, self, x, y, sample weight. So here we'll be implementing or inputting our training set, which is x underscore train and y underscore train. So that's it. So we have fitted our simple linear regression model with our training set. So let's execute this. So let's execute our set of statements. So yes, it has been executed. So what we have done, we have imported a class which is linear regression. We have created a model out of it, and then we have fitted our regressor model into our training set. So what will this do now? So our machine learning model will learn from our training set, and then will be able to predict the values if any kind of a future new value arises. So let's predict the values now. Predicting the test set results. So here what we have done, we have already split our data set into training set and test set. We have imported the training model, and then now we'll be predicting the values with respect to our test set. So we'll create a variable ypred which is equal to our object dot predict method. So we'll be predicting the value, so we'll be predict using a predict method. So what will be our argument in this? So it will be based on our x test. So based on the values in the x test, we'll predict a value for it based on the model which our regressor has learned. So let's execute this. So let's execute this, and it has been properly executed. Now let's look at the values, which is y predict and y test. So these are the values. So instead of looking at manually, let's visualize this in a beautiful graph. So our next step involves visualizing the results. Visualizing the training set results. So for visualizing the training set results, we'll obviously use a class which is known as plot, and we'll use plot.scatter, and we'll input the training set x underscore trained, y underscore trained, and what will be the color of it? We'll actually color it as red, so it will be color as red. So this will be the points with respect to our training set. We'll use another method which is plot to plot this out. Let's input it as training set, training x train, then use regressor.predict value to input our prediction value with respect to our training set, and this will be our regressor line, which will be in blue. So let's mark it as blue. So this will just go. The next step involves putting the title. So plot.title. So what will be a title? The title will be salary versus experience. Salary versus experience with respect to training set. So that will be our title. And in the next step, if you want, you can obviously label your x and y axis. So x label. So what will be the x label over here? So you can just put the x label as years of experience. Years of experience. What will be a y label? If you want any y label, you can obviously put that. You can input y label as salary, and the last step will be to just plot it out. So just show it. So let's execute these steps. So as you already executed the y predicted values, let's execute this. So yes, looking at the graph over here, if you can see, this is our training set values. The red dots are the actual training set input values which are provided, and the blue line is the actual regressor line. So it will be very interesting to look at the test set results. So we'll actually copy the all the statements will be similar except some changes here and there. So let's look at that. So visualizing our training set results, we already seen the graph. Now visualizing our test set results, these are the statements. Plot scatter used to plot x test and y test, which are our red points, and your actual regressor line will actually remain the same because the regressor line or our regressor model has learned based on this training set, which has been provided as the input. So interesting to see the graph for our new values, that is our test set values. So let's execute this and let's see what exactly is the graph. So here is the graph. So these are our test values which we have imported from data set, and this is the actual simple linear regressor model line. So as you can see, it has actually predicted the value or predicted the linear model with respect to the lines as around 80 to 90%. Some of the points are not on the line, but approximately it's a best fit model which we can think of with respect to our machine learning. So it has actually learned from the training set which you have provided, and the results are in front of you. The test set results are actually very much best fitted to our machine learning model. So only some of the points are not exactly to our linear regressor line, but most of the points are similar or are near to our regressor line. So that is our machine learning, which is simple linear regressor model or the simple linear regressor line, wherein the line has been predicted and the test set results which you have inputted are actually very close by to our linear regressor model. So approximately it has predicted the values for the dependent variable, which is salary. So this is the power of machine learning. So that's what we need to analyze in our future regressor models as well. So this is a simple linear regressor model wherein we have already deal with only two variables, but as you go forward there will be multiple linear regression, there will be polynomial regression. So this is the simplest of all and very useful as well. So thank you very much. Hope you understood the entire simple linear regressor training and the entire simple linear model creation out of it. So what we have done, we have just implemented the data pre-processing template, and then we have split it into training set and test set. After splitting it into training set and test set, we have imported our training set, which is, so we have imported our linear regressor class, we have created an object out of it, and we have fitted the object into our training set. So our object will be learning from the training set. After that, we have used yPredict value to predict the value based on the test x test which we have segregated, and then we have plotted a graph. So the training set will be obviously a better line based on the training set results, but our more important area of concern was the test set results. So we have imported the x test and the y test, which are the red points, and our linear regressor model, which is the blue line, is approximately able to predict the values with respect to this line. So that's it for this time. Thank you very much. Hope you like this video. Till next time, bye bye.